Hi guys, so today we'll be solving this problem called count good nodes in binary tree. Let's read it. Given a binary tree root, a node x in the tree is named good if in the path from the root to x there are no nodes with a greater value than x. Return the number of good nodes in a binary tree. So, right, we've been given a binary tree. Binary tree means like it has two nodes, left and right, and yeah, we have this tree. Let's take the first example. So yeah, we have this tree where we need to return the number of good nodes in a binary tree. Good node is defined by if that node, if it's greater than the root node, and if there is nothing in between that node and the root node that is greater than the root node, then that is considered as the good node, right? So that is the answer, that is the possible solution for it. So in this tree, entire tree, we have 3, 4, 5, and 3 like this, right? So we have this, and then we come to this, let's say this 4. So 4 is a good node because it is greater than the root, and there is nothing in between which is greater than the root, right? So this is a good node. 5 is good node because there is nothing in between which is greater than 5 from the root node till that. So that is why it's a good node. 3 is also a good node because yeah, nothing is there in between greater than the root node. This and yeah, when we come here, we know that 4, like if you want to come here, right? So reach here. So 4 is there, which is greater than this node. That's why we do not consider that one, right? Uh, and then similarly here, we have 1 and then 3 and then 3, right? So 3 is almost like greater than or equal to the node, right? So if you see here, if in the path from root to x there are no nodes with a value greater than x, right? So nothing is greater than x here in between. So that's why it will be considered, right, as a good node. Whereas here it wouldn't be considered because 3, it's actually smaller than the root node. So yeah, that is the idea. How we can solve it is just simple. Like we do a pre-order traversal, we compare it with, if it's like we compare it with the root value of that particular tree, and if it's greater than that root value, then definitely we say that this is a good node, right? And if not, then we keep on traversing. We'll do a pre-order traversal here, so that pre-order is like we do middle and then left and then right. That is the pre-order, traversal technique that we use, right? Let's get to the coding part in order to understand this a bit better, and we'll do the pre-order traversal there. Let's get to the coding part. So we'll do a pre-order traversal, right? So we'll maintain a function for it, and we'll pass root and also int minimum, which is basically the local variable for you know creating the so actually we'll create a global variable called maybe like good count, right? Equal to 0, and return good count. And this will be actually populated in the pre-order traversal. So in pre-order traversal, we'll have root and also int you know root value, maybe like something like which will be helping us to identify all. I am also like assuming that this will be actually storing the root for comparing with the root value, right? So that's what the idea is here of keeping this. Yeah. So this will be for maintaining the answer for comparing with the local variables, right? So right now we have if root equal to null pointer, then we just return from here, right? And if root value is greater than equal to answer, right? If that is the case, then we say good count plus plus, right? And then we do pre-order traversal, route left, and pre-order traversal, route right. And also we'll need to pass the minimum. So yeah, so here what we are doing, we're saying that when I come to like 4, so 4 will actually compare it with answer, right? So answer is basically nothing but the previous like the root value or the maximum root value that is so far, right? So 3 is the maximum root value, or going forward, if in this case when we are at 3 4 1, right? So 4 becomes that maximum value, so answer will be 4, and that will be compared to 1. And that's why 1 will not, 1 will not be greater than the 4 answer, right? That's why it will not be a good count or good node, and will not be considering that. Whereas when we do this traversal, 3 4 5s, right? So max answer is 4, and 5 is still greater than 4, right? So it will be considered as a good node. So basically this will be the maximum between the root value and the answer, right? And here also it will be the same, right? And yeah, let's run the code to see if everything is working fine. Yeah, just semicolon missing. Yeah, so I think some typo here. Yeah, that works. Cool. I hope you guys understood the problem. Thank you so much.